All right, today is Shapes Library. We're going to build this library of geometric shapes that we're going to use in other programs. Looking at it, we need to start with how do you create your own library? Instead of just using the Java library, we want to actually create our own today. So how do we do that? Well, we're going to use Netbeans to do that. So let's crank that up. Here's Netbeans. Okay, looking at creating a new thing. I'm going to close all these just to, well, maybe not. I'm just going to minimize them so they don't get cluttered. So these are older projects that I've been working on. But here we're going to say new project, but this is going to be a little bit different than normal. Instead of, that's open project, we want to say new project. New project, there it is. Instead of Java application, we're going to do a Java class library. And the only real difference here is, is that there's no main method. Okay, libraries don't have a main method because they're called by programs that have a main method, but basically it's just a library of classes that are grouped together in kind of a chunk. But so we're going to create this library and then see if we can link it that way. So let's try that. Java class library. Yeah, question. Doesn't have Netbeans? Okay, so what I would do is go to, go to Replit. It's an online tool. So you have this option at home too. If you go here, let me show you. We'll add this. That's another option. If you don't have Java installed at home, there's this browser-based development environment. So I would say sign up, and then come up with your own nickname, but make up an email and password. So you say create account. Yeah, so there.
I was using this one the other day.
Yeah, it got wiped because we're having trouble trying to get the computers to work. All right. Okay. So let me know when you have that up. But again, I'm recording it so that you can go back and listen. Okay, so then I say next. Now, big question is, where do I put this? We need to put this out on the server. Why do we need to put it out on the server? Is because that allows you to move machines. Say like today, this machine is being worked on, so he's had to move computers. It allows you to get to your stuff on the network from any computer in this classroom or even over in the engineering classroom. Okay, so you want to make sure to store this project out in your home folder. Remember, we made a link off the desktop to my home folder. There it is for me. So you would click on that link you made on the desktop. Remember, it has a little shortcut to the home folder. So click on that. I actually have a different setup. So my actual working directory is here on my Z drive. You don't have a Z drive. I do. And I made a little project folder here. Here's Netbeans projects. Maybe put it there. And I'm going to call this one, well, we'll see what we call it. Select project location. So now it's in the right place. And then I want to give it a meaningful name. So I would say this. I would say shapes slide, like that. We're creating our own library. All right, so you're in Replit? Cool. So now you have to just choose which programming languages we're using. So let's see. We want to use Java. Okay. And then here's your project. And we're going to create a new file. Let's see, where's new? This one? That's new folder, new file. Just say shape slide, like that. And then you can type along with us, okay? Does that work? All right. All right, so and then this question, use dedicated folder for storing libraries. Let's not use that for now. Yeah, what's up, Jacob?
Can we ask you a real quick robot question?
Sure, yeah.
I know I've seen this part around, I just don't know if it's something I just want to know if we had them, because that means I can start looking rather than just.
Yeah, they're in the, if you go into the engineering room, all the cabinets, I think it's the third cabinet in. That's where I put the oddball pieces from a long time ago. Yeah, but there's a bucket of them there.
It's not like I've seen them, I just couldn't remember and didn't want to tear the place apart.
Yeah, and there's also other gears that go with that, and that's also in the same bin. Okay.
Thank you very much.
Yeah.
Sorry to interrupt.
Not a problem. Okay, I'm gonna have to edit the video, it seems. Okay, so we've made our library, and you'll note our library is empty now. Okay, there is no source file. Again, there's no main method, so it didn't create one for us automatically. So now we have to create our first source file. So here we're going to create a new Java class, and we want to put it in this package. Notice it says default package, which surprises me. I figured they'd make a shape-slide package, but we'll just do the default package for now. Right-click on that, and then say New Java Class. So like we normally do.
And then we should just call it shape-slib?
No, we're going to actually call this one Rectangle. Now, we've been using rectangles since the beginning of the class, but the rectangles that we've been drawing are Java library rectangles. And the problem with Java library rectangles is they're not implemented in an object-oriented fashion. And the shapes that they provide you are not very object-oriented. And so what we're doing is we're putting a wrapper around it and re-implement. Yeah, we'll be able to do all of that stuff. So it'll be fun. Okay, so here, there's the name of the class. It's going to make a rectangle class for us. And it even puts your name in there. I don't know. So we're writing our own little library. Probably puts your student ID numbers, what I would imagine. All right, so here's our public class rectangle. We have to write this rectangle class. Now, so far in Chapter 2, all we've done is been using classes. We haven't been creating our own classes. So what does a rectangle class need inside it? Well, what are some characteristics of rectangles that we're going to need to know?
One, they're kind of longer than squares, but they still are technically.
Yeah, but if you were needing to draw it on the screen, what information would you need to know?
How big is it going to be?
Yeah, how big?
How long is it going to be? Where's X and Y?
Yeah, where it's going to be. So let's do that first. We say private. This is data that's private to this class. No classes from outside of this class can get access to it. We're going to say int, since we're working with pixels, and then we're going to say x. That's going to be our x coordinate. Yeah. 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 So let me add another one, and then call this one rectangle. So just type in rectangle. Yeah, it's good. And then .java, I think. We have to make it a Java file. So say .java. And then enter. Now it knows it's a Java file. Good. So we're in here. I didn't actually give you any heading, so put what you see on the screen up there. Just not all the grayed out text, but the stuff that isn't gray. Okay. Okay. So back to the video. So we need an x coordinate. We're also going to need a y coordinate as well. Yeah, int y. And then we also need to know its width and its height, because those can be different for rectangles. So you say private int width and private int height. For the longest time, English wasn't my first language. I always thought there was an H at the end of height. Height. Evidently, that's not a word. Okay, so now we have basically what we need to know to be able to draw this rectangle. We have its x and y coordinate on the screen, and we have its width and height. So in order for this to work, we need a way to be able to create rectangles. And the way you create things, remember, is you make a constructor, or you call a constructor. So we have to make a constructor for our rectangle here. So we would say this is public this time, so classes from outside of this one can get access to it. And then you say public, well, what's the return value for a constructor? And the answer is it's implicit, which means you don't have to state it here. It's invisible. All you have to do is type in the class name. Okay, and then it takes, well, let's do the default constructor first, okay?
I spelled rectangle rectangle on accident.
Oops, yeah, so you're going to have to rename it. So the way you do that is you can either, I would rename it over here, and then it says, do you want to refactor, and then say yes. But we can go back and fix that later. So here we have, this is called a default constructor. That's, if the user doesn't supply any parameters, this is the constructor to call. So I'm going to put a little note here and call this the default constructor. Now, this already actually existed. If you don't provide a constructor for a class, a public class, then Java will create one for you. It's usually not the way you want it. In this case it was, but here we're going to explicitly create the default constructor. And so what we do is we just set all the data, these are called instance variables or object variables. We set them all to 0. They have to have some kind of value when you call this constructor. And it doesn't really make a lot of sense to have a rectangle that has no size. So here you have this rectangle up at the top corner of the screen. It has no width or no height. So you won't be able to see it, but it exists in memory. Why would you create a constructor like this? Well, if you have to create, let's say, 100,000 rectangles, and you don't want to put in parameters for each rectangle, then yeah, maybe you use this constructor to do that. And then you initialize them later in a loop or something. Okay, so here, that's the default constructor. So with every class that I build, I always put in a default constructor, right? And this is the default. Now, what makes it the default constructor? It's a constructor that takes no parameters. The other thing to note about constructors is they don't return a return value, and it has the same name as the class. So this rectangle and this constructor name are the same. See that? That's how I know it's a constructor. Okay. So that's the default constructor, and then we'll do a normal constructor, I guess. I don't have to label it. But this time, why don't you copy this one, just so you don't have to type it all in again. But copy that one and put it there. This time, though, we're going to bring in parameters that allows us to initialize the instance variables inside of this object. Now, the instance variables are x, y, width, and height. So here we say int x, int x, int y, int width, int height. See that? So this is what you'd normally call. If you're creating a single rectangle, you know, this is the stuff you have to pass in order for the rectangle to be useful. But here, what we want to do is we want to set the instance variables x, this x, to this x that's coming in as a parameter. The problem, though, you have here is that they have the same name. See this x? See the x here is green, but this x is black? That's not good. What that means is if you say set x equal to x, you're just taking this x and assigning it to itself. And the compiler saying, you really want to do this? This doesn't make any sense. Why would you assign the same variable to itself? It's a no operation. So what you have to do is you have to be very specific about which x we're talking about. Now remember, there's that implicit parameter in every function that you call, that's part of a class at least, is the pointer to itself or a reference to itself, this object, this rectangle. So you actually use the keyword this. Ah, there it is. Now it understands. So what this is saying is take this x that's coming in as a parameter and assign it to this rectangle's x value. Okay, so those are two different.
Save that for the rest of the other ones?
Yeah, you just put the keyword this in front of it. So we're actually explicitly putting in this. Sounds like a Monty Python episode. We're putting this in. Well, we are putting this in, the actual word this. And now the compiler knows what we're talking about. So we take this value that came in as a parameter and we store it into this x. And then we take this value, this y, that came in as a parameter, and we store it into this y. So we take the parameters and put them in the private instance variables. Now, we get these warnings. Field can be... Good question. I guess it's when you click on like a data member, it shows you all the other places in the code where that data member is used, which is kind of handy actually. See, if I click on X up here, then it switches to X. So we'll talk about final later. So that's just a warning so we can avoid that. Well, no, this is like the only two we need right now, at least. We're going to have... Yeah, that would be a good name for it. Okay, so now we have constructors. That means we can build a rectangle. But the problem with this is, yeah, we can build them, but we can't really show them on screen yet. So we need to add some stuff for that. We also need to write a tester for this. How to do this? Oh, this is where it gets complicated. Let's not worry about the tester right now. I have to sort that out anyway. So what are the things you're going to need to be able to do with rectangles? Well, let's say you need to, well, we need to draw it, right? So we would say public void draw. This is our first method, right? Public void draw. And then we'll pass in graphics. And then we'll say G. And we're going to have to do something in there to draw it, okay? Notice how it doesn't know what graphics is, okay? So what we have to do is load the Java library that has the graphics class in it, and that's here. So you click on the little light bulb and it says add import for java.awt.graphics, and you say yes.
Create class for graphics and package.
Don't create a class. Import the.
It won't let me. Wait, can you go back to your one?
Yeah, there. So it's got a little light bulb here. If you click on that, yeah. And then what it does is just puts this up there. Another way you could do is just type this up on top. So if you're in Replit, just add this to the top of your folder, or say somehow it doesn't work. So now we have this draw method. It doesn't draw anything yet because we need to know a few more things. And then other things we need to do with rectangles. Well, we need to draw them. Oh, I know. See these? We need a way to set these and get these values from this class. Right now they're all private. And if you're in another class, like your main method, let's say, and you want to find the x location or the y location, or you want to change the width of your rectangle, you can't do that because you can't get access to these because these are all private. This is another object-oriented concept that's kind of hard to grasp, and it's called data hiding. You hide your data from the rest of the system. And the question is, well, why would you do that? Don't you want the rest of the system to have access to this data? And the answer is no, because of debugging purposes. If every project in the huge program can get access to your internal data into this object, then any of them can mess it up. And then when one of them does, you have no clue who actually did that. So in order to make this program maintainable and usable into the future, you have to put in all these precautions so that you don't have impossible to find bugs in your code. This is called defensive programming. Believe me, I've been there, spent many a sleepless nights looking for a bug, eating bad pizza, drinking Jolt Cola, sleeping under my desk, trying to find bugs like that. Yeah, you don't want to do that. From personal experience. Luckily, you don't have to. So what we need is accessors and mutators. Remember we talked about accessors and mutators. Another word for them would be getters and setters, or get functions and set functions for each one of these. Okay. So what you can do, which is kind of sneaky, is you can highlight these, and then what you can do is then generate the accessors and mutators. This just saves you some typing. Now, if you're not using Netbeans right now, then you'd have to type these in. But let's try that. This menu doesn't mean a lot, but it's called Refactor. Okay, this is a very powerful menu in here. It gives you lots of really cool things you can do. You can rename your class. So Sam, you are asking about how to rename stuff. That's the way to do it. And then push up, pull down. I'm not sure what that does. Extract interface, extract superclass. Oh my gosh. Lots of cool stuff. But this one here, Encapsulate Fields. Okay? Encapsulation is another big concept in object-oriented programming. And we're trying to take these private instance variables and automatically generate some code that allow us to get and set the values of the instance variables. There's a mouthful. So I choose Encapsulate Fields, and it gives me a list. Here's all my private instance variables, x, y, width, and height. And it says, well, do you want to create a getter and a setter for each of these instance variables? And I say, well, yeah. You mean I don't have to type all those in? And you say, yeah. Programmers hate typing these in. So a lot of IDEs do it for you because it's pretty formulaic, right? So check the ones you want. We want all of them in this case. And then you say refactor. And watch all this code that appears magically. I say refactor, boop. And then suddenly, you have all these get and set functions available. Now, they put them first in our rectangle, which is not where I want them. So I want to move them right away. But I didn't have to type them in. And I'm going to move them. That's rectangle. I always like the first thing in my classes to be the constructors, because that's what people are going to look at first. And we want to paste them right here at the bottom of the class before the private instance variables. I always want the private instance variables last, so paste them right there. And now you have the getters and setters, or the accessors and mutators, just right before the private instance variables. Yeah, there's no brackets. You just paste that whole section of getters and setters into that area. Yeah. Okay. So now we have all these great functions. If you look over here in our navigator for our class, we have this class rectangle. It's got a default constructor. It's got a regular constructor. It's got a draw method that doesn't have anything in it yet. Get functions and set functions for all the instance variables. You can jump around if you're having trouble. Say you have a long class and you want to find some of these things. You can use this little window on the left to find it. It's really smart. Well, this is looking a little better. We have these rectangles. We can change its values after we create the rectangle. That's good. Well, what's next? Well, next is the draw method, right? How do we actually draw it? Well, this is basically the pattern we're going to use for drawing. We're going to say graphics 2D and we'll call this G2 equals, and then we say graphics 2D again, in parentheses, and then we say G. So this is in the draw method. And of course it complains because it doesn't know what a graphics 2D is. What is that? So we click on our little light bulb over here. And then we say add import for java.awt.graphics2d. So that's another graphics library. Now the first graphics library that they made in Java wasn't complete enough, didn't function very well, and had a lot of problems. So what they did is they created a better graphics class that wraps around the old graphics class, and you can actually change your G into a G2, and that's what this does. This is called a casting operator, where you put a class name in parentheses that changes this G, which is a graphics object, into a graphics 2D object. But you have to load that import. So you say add import for java.awt.graphics2d. There.
Now this is a problem.
Yeah. Okay, so we'll pause right there. I'm going to come around and make sure that everybody's got this working. All right, welcome back. Let me open up our game. Yeah, I forgot to turn on the recorder at the end of class, so I'm just going to review what I changed. Sorry about missing it during class, but I think we can take a look at the code and see what I added after we're done. So we're working on the shape slide. Let's see the current state. We were in the rectangle class, I think. And what we're doing is we were right here in the draw event. We were trying to write that on the last part of the video cut off. And so the way we're going to do this is we're going to rely on our java.awt.rectangles. They know how to draw themselves. So what we're going to do in our rectangle is just going to, internal to ours, we're just going to make a quick Java rectangle and use that to draw with, because it knows how to draw rectangles already, so we don't have to do that from scratch, let's say. So here's the line where we convert the G into a G2. Then we create a Java rectangle. And notice the way we specify it. It's fully qualified, which means you have to put in the package name and then the class. The reason why we have to do that here is because we already have a rectangle class, the one we're trying to create. But this is our own rectangle class. And in order to differentiate from the Java rectangle class, you have to put this stuff in it. And again, we create just another rectangle, but here we have to do it again, so it's very, very time consuming. You only have to do this when you have a name collision. That's what this is called. We have a rectangle, they have a rectangle. We have to somehow show the difference between the two, so we have to do things like this. Just like our rectangle, it takes an x, y, a width, and a height. And then we just have it draw it. Now, the way Java does drawing rectangles, instead of having the rectangle draw itself, you have the G2 object, whatever that is, draw a rectangle, which is kind of backwards. So we're trying to fix that by creating our own rectangle class. So here we've drawn it. Now, here we have get x, set x, get y, set y, get width, the standard accessors and mutators. So none of this really changed that much. But we've added this ability to draw the rectangles. So let's go look at that. The code for testing that. So I go in the component class in our other package, our default package. And just ignore this for now. I'm going to put this in block quotes or block comments, so we don't, because I did a little bit more coding. I don't want that to confuse us quite yet. If we run it, we'll see that nothing really has changed. The rectangle still gets drawn in the right place. We draw it once and we move it and then we draw it again. See, we draw it once, we change the value of x, so we're moving it to the right, and then we draw it again. And that's what we're seeing here in our window. Looks good. All right. So, but now it's time to create a square class. In class, what I showed you is how not to create a square class. This time, though, I'm going to show you how to do it correctly. And so what we want to do is we want to create our own square class. And so you would right-click on this Shapes lib and say New Class, and then just type in Square. I've already done that. So once you've done that, you get something kind of looks like this, but we're going to fill in the insides of it. Well, first of all, I get a couple warnings from when I coded it earlier, and it tells me, hey, you loaded these imports, but you didn't use them. So we're going to whack those two. So you don't actually need those. So don't type those in because you don't need it. And then here's the really powerful part. This is the part that's the most important. Instead of just copying the rectangle class and making the rectangle class, or the square class, do everything the rectangle class does, what we can do is we can be a lot smarter, and we can use a feature of Java and most object-oriented languages to create a square, because a square basically is a rectangle. Why do we have to redo everything, rewrite everything, and copy everything? If we already can draw rectangles, we can already set the x and y and the width and the height. So instead of copying the code in rectangle and just changing all the names to square, what we're going to do instead is we're going to use something called inheritance. We want the square to inherit all the data members and methods that come with a rectangle, because a square is a rectangle. Why reinvent the wheel? So the way you say that in Java is you say the keyword extends. You say extends rectangle. It means it's a rectangle, but it's a little bit different. So we're going to specialize it a little bit. So that's the first thing. Is in your square class that got automatically generated, just add the keyword extends and then rectangle. This is kind of weird. If they try to build a square with no parameters, no x or y coordinate or side length, then we just want to call the default constructor. So what we do, and this is the odd part, is you just call the default constructor of the parent class. Now the parent class is rectangle. This is the child class. This is inheriting from that, kind of like you inherit characteristics of your mother and your father. So here all you just say is super. Now another name for a parent class is a superclass. So this would be a subclass. This would be a superclass. So you say, well, if I have to create a default square with no x and y location or size, then I'm just going to call the default constructor for the parent, which is the rectangle's parent. So you don't say rectangle here, you just say super. It looks kind of funny. Here's another one. Square, well, square we don't need a width and a height. It's the same, right? So why don't we just use a side length? So we only need 3 parameters for square. So we create a constructor that only has 3 parameters. But then when we create the object, we're going to need a length, or need a width and a height. So what we do is we just send in the side length twice, because they're the same for the width and the height. So you say super, which is the parent class, the rectangle's constructor, pass in the x and y we got, and then for the rectangle's width and the rectangle's height, we just pass in the side length twice. And that's all you need to do there. Now we have this idea of side length, so we kind of have to add that to the accessors and mutators. So we do that, and so we say get side length. Well, we're just going to return the width, because remember the width and the height are the same for a rectangle. So it doesn't matter which one we choose here. We could choose width, we could use height, we could choose height, but we return one of them, and that would be equivalent to getting the side length. So we're kind of translating width into side length. Here's another one where we're setting the side length. We have to be careful on this one because, again, in the underlying or the parent class, it has 2 sides. It's got the width and the height. So if they pass in a side length, we have to change both the width and the height of the underlying rectangle. So that's what we do there. Now you might get an error right here. It'll say, hey, wait a second. These are private. You can't change You can't change the width. You can't change the height. Those are private instance variables inside the rectangle. We're not inside the rectangle, so you can't do that, it will say. So what we have to do is go back to the rectangle and we say, okay, for all other classes, we don't want those other classes to access the private data members inside a rectangle. But we do want to let our children be able to do that. So anything that extends rectangle, we want to let them those classes have direct access to our data. But we have to say that in advance. So we go into rectangle here, and instead of saying private here like we did originally, we need to change this to protected. What protected means is that for all other classes in the program, they can't get to these directly. But if a child class tries to get to these, you can actually just type in X. You don't have to call get X and get Y. These accessors and mutators, if you're a child of rectangle. Now the other interesting thing about the square class is we don't have to specify any of the other accessors and mutators because we inherited all of those from rectangle, like getX, setX, getY, setY. All of those were inherited by the child class. And then the other thing that's weird is notice how the square class has no draw method. It's just not there. So how do we draw squares? Well, the interesting part here is we already know how to draw squares. We inherited the draw method from rectangle. And as long as a rectangle has the side length stored in the width and the height, which it does, we can just rely on the rectangle's class's draw method to draw because it's still going to work. To draw a rectangle or to draw a square, is it any different than what we have here? And the answer is no. So there's no need to create another draw event for the square because the one in the parent is sufficient for our needs for squares. So you don't have to add a draw method. You don't have to have accessors and mutators for a getX and getY, setX and setY, set width, get height. All those are inherited. The only thing you have to do in square is a couple constructors and create this concept of side length. But really, we're just hiding the fact that side length is just the width and the height of a parent rectangle. And that's it. Your square class is done. Very cool. So how do you try that? You go to your component in our tester class, and you would type in this code. And so now you create a square, call it a square. So that's the class name. That's your name for their class or the object. And then you say the class name again. And then I'm just moving it to the right a bit so you can see it on the screen a little bit better. And I'm moving it down the screen a ways too from where the rectangles are. And then I draw the square. So let's see if we see our square. And sure enough, we do. Yay. So that's how you use inheritance to simplify creating other geometric shape objects. As long as you do your inheritance correctly, you can save yourself a lot of typing. And we're going to do much more of this coming up. We have other classes to create, like the triangle class, the circle class, the ellipse class, and a bunch of other ones. We're going to go through each one, and then we're going to use those in our other programming later. So we're going to use this library not just here, but actually in other programs. That's why it's called a library, so you can use it in other places. All right, that's all I had for today.